Center for Fuel Cell Technology, ARCI, Chennai, and he obtained his PhD from CECRI Karaikudi in 2006. He has also worked as scientist in SPIC Science Foundation, Tuticorin and Chennai in the area of hydrogen fuel cells during 2006 to 2008. He did his postdoctoral work on renewable energy integrated hydrogen energy system at Kitami Institute of Technology, Japan during 2009 to 10, and later he joined at CFCT-ARCI in 2010. His research interest includes hydrogen energy technologies, electrochemistry, electrochemical process and energy conversion systems, electrolysis, electroplating, and water treatment. Currently, is focusing in the area of electrolytic hydrogen generation and PM-based system, and developed a PM-based electrolysis system up to 5 kg per day hydrogen production capacity, and working on establishment of automated PEMFSC assembly line for fabrication on PEMFC stack, which is first of its kind in India. With over about 2 decades of experience in the area of electrochemical hydrogen generation and fuel cells, he has contributed to transfer 5 technologies to industry in the area of applied electrochemistry. He obtained 5 patents and published more than 45 papers in journal, conference, and 4 book chapters. He delivered about 75 invited talks in various programs and received outstanding scientist in the area of hydrogen energy technology from Venus International Foundation in 2016. He has also guided about 39 students for their dissertation work, including doctoral and postgraduate students, and serving as reviewer in various reputed international journals. He executed about rupees 20 crores worth of sponsored project as PI and co-PI obtained from the various funding agencies. He is a member of professional societies like Hydrogen Association of India, Electrochemical Society of India, Society of Advancement of Electrochemical Science and Technology. He has also nominated as a member in adoption of hydrogen technologies in upstream sector formed by Ministry of Petroleum and Natural Gas, Government of India, and member in the Committee for Development of Capacity Building Programs and Certification in line with standards developed for the hydrogen subject area formed by Pro Vice Chancellor, Indian Maritime University on April 2024. He is also an Industry Technology Advisory Board member at Green Hydrogen and Hydrocarbon Tech Consortium at IIT Madras, Chennai. He is an Executive Committee member at Center for Energy Storage Technologies, Anna University, Chennai, and COE in Automotive Technology, MIT, Anna University, Chennai. His biographical profile selected and included in 32nd edition of Marcus Who's Who in the World 2050. Sad is currently working as a senior scientist in ARCI Center for Fuel Cell Technology, IITM Research Park, Taramani, Chennai. With this short introduction, I call Dr. Balaji sir to present his title on hydrogen fuels. I welcome you, sir.
Thank you, ma'am. Thank you, madam. So thanks for extending the invitation to be a part of this Atal FTP. I'm happy to be here. Good evening to one and all. Can I share my slides, ma'am?
Yes, sir.
Is it visible, madam? Right now?
Yes, sir. It's visible, sir.
Is it in slides mode only? No, I think. So,
sir?
Yeah, is it in full slide mode? No, yeah.
Yes, it's full slide.
Okay. So thanks once again. So the topic which I would like to discuss today is on hydrogen energy based mobility and power backup applications actually. So basically the word that hydrogen which are popping up recent times in India because the whole global world is trying to find out whether the hydrogen would be the alternative fuel and which can be sustainable for longer run. So that is what the very ambitious goal which is being also targeted by our government of India. And because we talked about hydrogen for from very long time, and people are trying to use as a kind of alternative fuel. But when we heard about the talk on hydrogen, basically we would think that it's a hydrogen, it's an atom bomb actually. So, but now we try to handle the hydrogen and we are trying to use as a fuel and for power application for energy related application especially. So there are a lot of steps which is being involved in the hydrogen energy sector actually. So the topic which I am discussing today on at the it is a final uh, this is a kind of utilization of the hydrogen aspect actually. So before utilization hydrogen, so because there are other important steps are there actually. Basically, it is non-existing fuel because it is not existing as such actually in the earth. So it is being existing as a kind of hydrocarbon or water actually. So the first step is to we need to get it extracted from the these major source of hydrocarbon or water. So when you try to extract or when you try to separate the hydrogen from these two major feedstock of hydrocarbon or water, we need to spend a lot of energy actually. So whether it may be in the thermal form or it may be in the electrical form, so we have to spend a lot of energy to get out, I mean, to separate the hydrogen from these carbon, hydrocarbon or water actually. So depending upon the feedstock, whether it is hydrocarbon, then it is a gray or blue because the hydrogen is colorless. But when you try to generate hydrogen from hydrocarbon, obviously we will end up with a carbon monoxide, carbon dioxide kind of greenhouse gases actually. So if you're emitting such kind of gases along with hydrogen generation, then that hydrogen is being colored as gray hydrogen. But if you have a mechanism of generated CO2 and which is being captured and used for some other application, then that hydrogen is being colored as blue hydrogen because you have a carbon capture system along with you are generating hydrogen from hydrocarbon. And the ultimate aim of people is that when you generate hydrogen from water, we would end up with hydrogen and oxygen actually. So that is environmental friendly. And that too, if you try to couple this electrolysis process, that means the energy from the renewable and using the renewable energy, get splitting the water molecule into hydrogen and oxygen. So that is a green route of generating hydrogen. Then the color of the hydrogen is being green hydrogen actually. So this is the major classification of about hydrogen and its color and how it is being produced. But once the hydrogen, though it is being produced, because it's a lighter gas, so you have to store it in a compressed form so that you can carry more hydrogen in a particular cylinder. So the next step is hydrogen storage, which is also very, very critical because it is a lighter gas, so it will occupy more volume. So it has a low volumetric energy density, but high gravimetric energy density. So that is the beauty of hydrogen. So it occupies more volume, but you have to be compressed if you want to carry a single cylinder for vehicle application or other things. You need to carry minimum 5 to 6 kg of hydrogen on the vehicle actually. So 5 to 6 kg of gases has to be handled in a compressed manner. So that is very, very difficult actually because you have to handle high pressure cylinders. So that is storage is another important area where we need to focus on how effectively we can store hydrogen gas. So once generated, then storage, then how do we transport actually? So even if we generate hydrogen and it has been compressed and store it, and if it is being stored, so and how do you transport? So the transportation mechanism is also important. So before coming to hydrogen as a energy carrier and use it for backup or mobility application, so these three steps are most important actually. So with this
Excuse me, sir.
introduction,
Sorry to
yeah, please.
sir.
Yeah,
Sir, slide, it's not moving, sir.
yeah. I will change it.
Okay, sir. Thank you.
Yeah. So before getting into the topic, just I would like to give a brief introduction about our institution. Because ARCA is nothing but Advanced International Research, Advanced Research Center for International for Powder Metallurgy and New Materials. Because we started this institution basically with the focus of major metallurgical and material research institution. But later point of time, we also get into energy related R&D activities. Basically, we headquartered at Hyderabad and we have two centers at IIT Research Park in Chennai. So the Center for Fuel Cell Technology, where I'm coming from, and Center for Automotive Energy Materials section. These two centers are functioning at ARCA in Chennai. And the major focus of our ARCA, which is unique institution where we work on R&D, it's not only in the laboratory scale, we aim for high pilot scale so that we can transfer the technology for easy industrial adoption. That is the uniqueness of ARCA research institution when compared with other R&D and academic institution. We try to bridge the gap which is existing between academic and commercial and R&D sectors actually. So far we have transferred about 16 technology to the 28 industry in various aspects. So coming to our center, which was established in 2004 actually. So with a major focus on hydrogen fuel cell, that means hydrogen utilization aspects. And apart from that, we also do concentrating on hydrogen generation R&D activities and storage also. Apart from three main activities, we also work on other energy storage device like battery or supercapacitor, which are kind of spin-off technology because most of the component which is being used for these fuel cell and generation and storage aspect can also be used in making other energy storage device like battery or supercapacitors. So it's a kind of spin-off technology. We do concentrating on that particular area also. Uh, and ultimately, we also have a kind of a manpower generation because we have a program of hiring JRF, SRF for our R&D activities. And major advantage is that whether they can join with us in with and without gate category. Once if they join with us, then we will support them for 5 years with full stipend. And they have the liberty to register the PhD any of the NITs and IITs in India. So we will support them for 5 years as external candidate, and they can register a PhD. And at the end of the year, they will have a PhD degree from the NITs or IITs where they register, and they will get a good exposure on high technological readiness level R&D activities also. So that is also one of the vertical which we are working on generation of skilled manpower to this hydrogen energy society. So when we talk about net zero, because that is the talk globally people are focusing to attain the zero value. So we have to go back from carbon to hydrogen in backward direction because the hydrogen which is next to the zero, which is atomic number close to 1.008, which is close to zero. So we have to go back in the periodic table from moving from carbon to lithium. So lithium is a kind of battery is a kind of energy storage medium, then if you want to achieve zero, you still have to go back to through hydrogen, so then only we can attain net zero. Here, I would like to emphasize that why we have a battery as a kind of energy storage medium. So why do you want to go with hydrogen as an energy storage medium? Because if you want the energy, hydrogen is not an energy generation process, it's an energy storage process because you have to get the energy from the renewable or somewhere else. And using that energy, you have to split the water molecule or hydrocarbon and get the hydrogen, and it has to be stored, which is similar to like battery. So battery, what will you do? We will take power from the renewable or some grid, and it is being stored in the battery. And whenever you require, you can discharge the battery and get the power. So same thing in the case of hydrogen, you generate hydrogen from hydrocarbon or water. Especially if you take consider water as the source for hydrogen, then you have to generate hydrogen through water. Once if you generate it, so it has to be compressed and it has to be stored. Whenever you require, you pass this stored hydrogen in a same device or similar device with the help of oxygen as oxygen, we can get back power and water actually. So It's a reverse of electrolysis process. Fuel cell is nothing but reverse of electrolysis process. Normally in electrolysis process, we will give electricity. Using that electricity, water is being split into hydrogen and oxygen. Whereas in the fuel cell, if you pass hydrogen, oxygen or air in the system, you will get water and power. So it's a kind of discharge and charging mechanism of battery. So in that case, this hydrogen and the battery both are being considered as a energy storage medium. So when we have a battery as energy storage medium, why do you want to go with the hydrogen? The answer for that question is that I will come up with number at the end of my presentation. Before that, so the battery storage device cannot be scaled up to kilowatt level or in some cases megawatt level. But if you want to store energy in the form of gigawatt or terawatt, the hydrogen will be the best option because the battery cannot handle the gigawatt power, or even if it handle the maintenance and the cost and the energy storage space and all those things, which is huge actually. So the battery can be stored up to kilowatt range of energy storage, but if you want to extend energy storage medium to gigawatt level, then hydrogen will be the best option when compared with battery based devices. So as I said, there are three energy storage medium supercapacitors like lithium battery and hydrogen. All are comes under energy storage category. So in this, there are characteristics in terms of energy storage, energy density, power density, and cycle life, and self-discharge rate, and life and cycle life actually. So in all those cases, the hydrogen is on par with all the so energy storage medium. And the supercapacitors and lithium battery, as I mentioned, it has a limitation of energy storage in terms of kilowatt or megawatt level, whereas the supercapacitor is widely used only for the surge energy storage, kind of surge power wherever it is required. Actually, it cannot be used for any other energy storage applications actually. So in that category, hydrogen will be the dominant hydrogen energy, energy storage medium when compared with battery and other supercapacitors. And when you talk about the hydrogen, and there are other key aspects which I discussed: generation, storage, and transportation. Finally, it comes to utilization. So apart from these four important steps, there are many intermediate steps which we need to take care, especially arriving the standards, safety, and codes actually, which are also equally important because hydrogen is highly explosive gases, which need to have a proper codes and safety standards, unless otherwise it will not be practically viable. So the development of codes, safety, and standards is also parallelly important. And always the skill and education on particular on energy technology is also equally important. So these are the various vertical where we need to take care when you want to use hydrogen energy based mobility or backup power application, especially for smart cities like as I said, the first step is generation, which is being classified based on the amount of carbon dioxide which you are emitting from the feedstock while generating hydrogen. So in that case, there are brown hydrogen, which has a huge CO2 emission per kg of while per kg of hydrogen, which comes around 18 to 20 kg per CO2 per kg of hydrogen. And in terms of gray, is slightly lower than the brown hydrogen because feedstock is kind of natural gas where we have a single carbon molecule. So the emission of CO2 is being controlled and it is lower than the brown hydrogen, and it lies in between 10 to 12 kg per kg of hydrogen. And the same hydrogen, which you have a proper mechanism for carbon capture and sequestration, then it is being colored as blue hydrogen. And ultimately, if you generate hydrogen from the water using renewable energy, then it is a green, which is have a zero carbon footprint, and the emission of CO2 is almost zero while producing per kg of hydrogen. So this is a major classification of hydrogen generation, without which we can't go for any application point of hydrogen actually. So, so as I said, when you generate hydrogen from the hydrocarbon, obviously we will end up with carbon monoxide and carbon dioxide, and we need to have a proper carbon capture mechanism. Unless otherwise, the advantage of real advantage of hydrogen energy may not be appreciable. So, but if you get the hydrogen from the water as the source, then you will end up with hydrogen and oxygen, which are harmless. I mean, environmentally harmless. So you can get a pure hydrogen through water using renewable energy. So in here, you cannot consider the grid power for electrolysis or any purpose. So you have to consider the renewable energy power. Using the renewable energy power, you can split the water molecule and get the hydrogen actually. So that it is very well established process that is called electricity through electricity. That is electrolysis process, which is well established and demonstrated. Whereas in the case of thermolysis, is nothing but getting heat from renewable energy, and using that heat, that water is being directly split into hydrogen and oxygen. So here the disadvantage is that during the thermolysis process, the emission of, the possible recombination of hydrogen oxygen which is being produced is more. So the recombination is chances are more, so that the technology is not being highly mature. So, and coming to photolysis, photolysis is nothing but the sun has enough energy to split the water molecule into hydrogen and oxygen. But obviously, this fortunately, this water does not have any energy absorption capacity. It is transparent. So water remains as such water. Otherwise, water will be always in the form of hydrogen when in contact with the solar power, solar energy. So, but there are material which can absorb the solar energy from as a photon, and the photon is being converted into electron, and that electron is being used to split the water molecule into hydrogen. So, in this photolysis process, it is a combination of photon to electron, electron to hydrogen. So these are two-step combination. That's why the lot of energy losses will occur. So the efficiency from renewable energy to hydrogen is very, very low. It's close to $3 to $4, 3 to 4% only. Whereas in the case, if you split the two phenomena like photon to electron, that is called photovoltaic power, and using that electron and do electrolysis, you will end up with hydrogen. So because here you are splitting the photon to electron as a one technology, and electron to hydrogen through electrolysis another technology. So the efficiency is being higher. So that's why these electrolysis routes are being much preferred, and technology has been demonstrated for hydrogen generation. So in this electrolysis process, basically water. So when you use water as the energy, water as the source for hydrogen, you have to give electrical energy. So theoretically, we require about 35 units of electricity to produce 1 kg of hydrogen. But practically, because of the material limitation and other cell resistance and the compound resistance, the energy requirement per kg of hydrogen production is almost double. It's close to 50 to 60 units of electricity per kg of hydrogen. So here the lot of this hydrogen cost is being determined based on the energy input which you are giving for its production. So in the case of natural gas, we need to supply thermal energy. So it is much cheaper than the electrical energy. Obviously, the cost of the hydrogen has come down to $2.5 to $3.2 per kg. Whereas if you use nuclear energy, that means high thermal energy, and directly using that thermal energy, directly splitting water molecule into hydrogen and oxygen, obviously we will end up with low cost energy because both are in thermal energy and carbon as the feedstock. Whereas in the case of electrolysis process, as I said, because it has a high energy intensive process to generate hydrogen from the water, and it lies about, as I said, 4.4 to $7.4. So any method which you are adopting for generation of hydrogen, ultimately it is being categorized, it is being employed based on the cost of hydrogen production. So the cost of the hydrogen is a major bottleneck for easy implementation of hydrogen energy based mobility or backup power application. So, and apart from the hydrogen generation, as I said, the another step is storage, which is also equally important because it's a low molecular weight and it occupies low density and it occupies more space. So you have to you have to compress the hydrogen in a particular manner so that the gravimetric and volumetric energy density can be increased. And the kinetics, because when you want to compress the hydrogen, you have to apply some energy. So that the kinetics of the particular and heat transfer and the efficiency, all things are need to be considered when you try to use hydrogen as a storage medium. And there are three forms which we can store hydrogen: compressed gas, liquid gas, and condensed state, because solid in the form of solid also. So among these three way of storing hydrogen, the compressed gas is economically viable, and it has a we can store hydrogen at elevated pressure up to 700 bar. Whereas in the case of liquefying hydrogen, which is very energy intensive process, because the amount of energy which you require to liquefy the energy hydrogen, which is higher than the amount of energy which you want to generate hydrogen actually, which you want to generate. So it is energy intensive process. So liquefaction of hydrogen and storing in the form of liquid is not it is not an economically viable option except a niche application where the space can application it is required. Wherever niche applications are there, then liquid hydrogen storing hydrogen in the form of liquid is viable. So whereas in the case of solid form of storing hydrogen, because you have a hydrogen gas, and when you apply some pressure or temperature, you can store in the form of metal hydrate. So there are some metal which can have an affinity towards hydrogen and form a metal hydrate when you give some energy input. So, but if you give the same energy and you can get back the hydrogen from the metal hydrate. So this is kind of condensed state of storing hydrogen in the form of solid. So among this liquid, gas, and solid form, the gaseous form is economically viable and it is being widely adopted. And there are main challenges in the hydrogen storage, especially the durability, because when you try to use durability, use condensed matter of storing hydrogen. So how much time you can absorb and dissolve the hydrogen in the particular material. So the durability of the material is also one of the key challenges in terms of storing hydrogen in the solid form, and the efficiency, because how much amount of energy which we need to spend to store hydrogen, whether the same energy which when you want to release the hydrogen from that particular material also key important. So ultimately the energy efficiency of the storage and distribution of hydrogen is most important, and it is also a challenging, and especially the refueling times, because how much the provide faster refueling times for the mode of to be considered viable, because when you want to refueling or you want to recharge, the time refueling time has to be minimum. So then only this hydrogen storage mechanism will take off. And ultimately the cost, which is most important, especially for the vehicular application, right now it is too high and it make it unavailable for all sectors actually. And so if you want to store in the form of gaseous form, so we need to have a lightweight storage canister, lightweight storage cylinders, because this hydrogen has affinity with metal to form a metal hydrate that leads to hydrogen embrittlement. So we have to have a so we cannot store hydrogen in the steel cylinder at more than 150 bar. So if you want to compress the hydrogen at elevated pressure, maybe more than 2 to 3, 150 bar, then we need to go for other alternative material which does not have any hydrogen embrittlement property. So in that case, the carbon composite cylinders are much appreciable. So it can handle hydrogen at elevated pressure of more than 700 bar. And even if you store hydrogen at that particular pressure, it does not have any reaction with any carbon-based material and hydrogen, and it is also much safer and weight of the cylinder is also very, very less when compared with steel cylinders. So the volume and weight is also equally important when you considering the hydrogen storage aspects. So let us assume if you try to we address these two key steps of generating hydrogen much cheaper cost, and we also have a mechanism to effectively store hydrogen. So ultimately the final aim of this hydrogen is to use deliver a power. So there are various conversion devices are there to convert hydrogen into power. So, but why do you want to go with the fuel cell route is that the efficiency for the conversion of hydrogen into power is higher when compared with other energy conversion devices. Like even you can use hydrogen in the IC engine and you can deliver power, but the efficiency is very less. It's close to 20 to 25%. Whereas when you use through fuel cell, so the conversion of hydrogen to power efficiency high. So that's why the fuel cell is being considered as the ultimate option to convert hydrogen into power. But and when you handle hydrogen and air or oxygen as the oxidant, so the safety is one of the key parameters and reliability is another parameters. So this fuel cell based system has a reliable and durable and which can be deployed with any service requirement in range of environment, whether it is a backup power application or mobility application. So it is really much reliable than any other conversion devices. And another key important aspect is that the responsive time. So whether it can immediately deliver the power as soon as when you inject hydrogen in the system. So yes, the fuel cell will do the job. It's a faster startup and rapid response to the power demand actually. So these are the four important factors which is pushing the conversion of hydrogen into power through fuel cell actually. So the fuel cell, when you talk about the fuel, is basically electrochemical device. So when you talk about any electrochemical device like battery, you must have a positive and negative electrode, and you must have a electrolyte to carry the conduction between to carry the ionic conduction between these two electrodes actually. So depending upon the type of electrolyte which you are employing for fuel cell, it being categorized majorly in 5 different pattern. One is proton exchange membrane, where this proton is being considered as the ion exchange medium, and it it conducts the hydrogen oxidation, oxygen reduction reaction. And solid oxide, where the oxide conduction will be the predominant, and this oxide conduction will take place only at high temperature. That's why it is being used only for a stationary application, not for mobility application. The molten carbonate and phosphoric acid fuel cell is a kind of alkaline acidic acidic based environment, and it is being used for some certain application. But instead of hydrogen as a fuel, you can use methanol as a fuel. So when you inject methanol as a fuel in the system, it generates hydrogen instinctively and then it delivers power. So because of this combination of generation of hydrogen from methanol and hydrogen to power, so the overall power density and energy density for methanol fuel cell is low. So it being used only for consumer electronics application. Other than that, it cannot be used for any application. So depending upon the type of electrolyte and the operating temperature, classifies the fuel cell into 4 or 5 different types actually. So among these 5 type of fuel cell, why do you want to go with a PM fuel cell base is that, as I said, is basically electrochemical device. In any electrochemical system, positive or negative electrode, inter-electrode distance has to be as close as possible. So it will enhance the efficiency of the fuel cell, because if you consider a polymer membrane, the the polymer electrode membrane as the electrolyte, and as well as the gas separator, it has a dual job actually. It can act as electrolyte as well as the separator. And on each side of the membrane, you can coat the electrocatalyst. One side will act as a positive, one side will act as a negative electrode, and When you pass hydrogen and oxygen in the respective compartment, it generates electrons, and the electron is being used for any power generation application. So, so the simple configurations of fuel cell, this fuel cell is opening applications for wide range of application, whether it is stationary or transport application. So if you consider like a battery, the open circuit voltage, if you take any lead acid battery or lithium battery, the voltage of the open circuit voltage, because at no load conditions, each energy storage, energy conversion device has its own open circuit voltage. Like that, the fuel cell has also the open circuit voltage of close to 1 volt for each cell actually. But when you draw the current from 1 volt, so the voltage is dropping down as seen in the figure. So the voltage is dropping down from 1 to 0.1 because that decides the efficiency of the fuel cell actually. So if you draw more current, the voltage should be in ideal condition, it should be straight, whereas in the practical condition, it is coming down. If you see this red color arrow, like battery discharge curve, the fuel cell discharge curve will be like this actually. So depending upon the operating voltage, the fuel cell efficiency is being determined. In the case of PEM, it is being operated 0.6 to 0.7 volt per cell. Then efficiency is close to 55 to 60% efficiency. That means the hydrogen is being converted into 50% as a electrical energy. The remaining 50% will be in the thermal energy. So the overall efficiency of the fuel cell is close to 80%. So if you assume, if you develop a 1 kilowatt fuel cell system, it also produces 1 kilowatt heat actually. So, but that heat is kind of low grade heat, which cannot be used other than room heating purposes. So these are the major important component for any fuel cell arrangements. Only is the electrode substrate, where you need to coat electrocatalyst on the substrate, and the platinum-based electrocatalyst, and the membrane, which will take care of the ionic conduction as well as the separation of gases. And apart from that, you need to facilitate the hydrogen and oxygen in the respective compartment. So in order to facilitate this flow of oxygen and hydrogen, you need to have a proper flow channel pattern actually, which will take care of the equal distribution of the gases on the catalyst surface, which will ultimately deliver the good power density for any fuel cells. And as I said, when you want to use fuel cell for a power generation, we ultimately end up with water as the byproduct actually. So apart from the power, the water is also one of the byproduct. So pure water. So you have to effectively evacuate the water from the overall system. Otherwise, it will block the catalyst surface further, and it will not allow for the hydrogen or oxygen molecule to enter into the respective catalyst performance. So, so the effective water management is one of the key parameters which
இதுதான் உனக்கு வீசு கையை அந்த பக்கம் இப்படி வச்சுக்கலாம் இந்த கையால இந்த பக்கம் வைக்க முடியாது
which we need to be
நீ அப்படி வெயிட்
உடஞ்சிட போகுது சரி இப்ப டிஃபன் இல்ல நீ போய் டிஃபன் வாங்கிட்டு
இந்த காசு
there are some cross talk.
சப்பாத்தி தேங்காய் சட்னி உண்டு எனக்கு சப்பாத்தி தேங்காய் சட்னி
இந்த வண்டி
ஏன் வண்டி தான் வெளியே வைக்க மாட்டீங்களா
பத்தா அந்த மாத்திரையில ஏதாவது காசு இருக்கான் மாத்திரைக்கு கொடுத்தனால
Excuse me, somebody is yeah. So apart from the water management is one of the key aspects which we need to consider, because the water has to be effectively managed within the system. But at the same time, this membrane, which will take care of the ionic conduction between the positive and negative electrode, this ionic conduction will also be effective only the membrane is hydrated. So the membrane should be, if you want to make hydration, then the water should be always there. But at the same time, if you allow the water is to stay more time within the system, then it will also hinder the oxidation of hydrogen and reduction of the oxygen. That means power generation. So you have to have an effective water management within the system, so that the power production will not be interrupted actually. So apart from the water management, as I said, each fuel cell will also produce heat as a byproduct. So if they develop 1 kilowatt system, 1 kilowatt heat and 1 kilowatt power will also be produced. So you have to have an effective thermal management system where whatever the heat which is coming out from the fuel cell has to be cooled down. So you can operate the system always at constant temperature of 50 to 60 degrees Celsius. So the generated heat can be used for room heating purpose actually. So the using some phase changes material. So that concept is widely adopted in the developed countries like Europe and US. So they use low temperature fuel cell in two kind of application, one for power generation and another for heat management. So the effective thermal management is also equally important to get the maximum efficiency from the fuel cell. So as I said, there are various process phenomena which is being taking place inside the fuel cell system actually. Because as I said, if you are not properly evacuate the water from the system, then flooding will happen. Or if you are not properly supply fuel, then the starvation, fuel starvation will also happen. And if the fuel starvation happens, then obviously the positive electron will become negative and negative electron will become positive. So, and because of this, over a period of time, the catalysts which are being coated on the membrane will lose its activity because, and overall, it loses the performance of the fuel cell. So each parameters has to be considered: effective water management, effective thermal management, and effective fuel utilization. All these factors are important like other engine like IC engine. Fuel cell also, these major phenomena need to be considered for the effective operation of fuel cell. So apart from the fuel cell, as I said, fuel cell is a final utilization aspect. So you need to have a proper, if you want to develop a PM fuel cell based power generation device. So apart from the fuel cell stack, you need to have a proper fuel supply system. Okay, and air supply system and the power, because the fuel cell will produce DC power like battery. But if you want to make because it's a, though it is a DC generation power, but it is highly different from the battery. The battery will deliver low current and high voltage, whereas in the case of fuel cell, it is reverse: high current and low voltage. Even at 0.6 volt per cell, you can draw maximum 200 amps or 300 amps. So the designing of power conditioner or powers is most critical. So whatever the inverters or converters which are meant for the battery may not be suitable for the fuel cell, because entire power electronics are entirely different, because fuel cell is being operated low voltage and high current, whereas in the case of battery, it is being operated at low current and high voltage. So development of power condition in order to get AC as a power output is equally important. So apart from the chemical and chemical engineering aspect, there are a lot of power, electrical and mechanical and other interdisciplinary engineering team is required when you want to build up as a PEM fuel cell based power conditioner devices. So, and obviously, if you want to deliver constant power and if you want to make the system always sustainable, you must have a effective control strategies and electronics actually. So, but in the case of fuel cell, you need to have a various phenomena: heat production, water generation, fuel consumption, air consumption, and the diffusion process. So all these phenomena are being controlled by current, not by the voltage. So the control strategy, establishing control strategy should be under current driven process, not voltage driven process. So most of the control strategy and analytical will be driven by the voltage, whereas in the case of fuel cell, this control strategy and electronics has to be driven by the current controlled manner actually. So that is the uniqueness when compared with battery or other energy storage based device. The developing control strategies and electronics is entirely different from battery and supercapacitor. So with this basic R&D, basic understanding about the fuel cell system. So the major activity at CFCT is that hydrogen generation and the fuel cell. And this is the pathway normally which we adopt for making fuel cell based power generation application. So normally we have a two pathway mechanism. One mechanism is that we will buy the commercial component and we will make our own commercial material and we will make our own components for making fuel cell. Once the fuel cell stack is ready, we will also develop a balance of system like a air supply system, fuel supply system, and power conditioners and thermal management system. And we will integrate with the core fuel cell stack and we will make as a system and a product. Once the product is there, wherever this hydrogen is available, and we do the field trials and delivering the power. And second pathway is that we also do working on developing our own materials. And if it is working smaller scale, then we will scale it to higher stack level. So this is a two-way mechanism. So one is the commercial material, and we will make our own component and making fuel cell as a system. That is one pathway. And another path is we also work on developing our own material. And if it works in fine in lower level, then it can be upgraded to higher level also. So this is our pathway mechanism for technological development. And our institution, especially our center, has done enormous work on this particular area, and we have about 20 plus 2 decades of experience in this sector and trained more than 150 manpowers, and we have very good patents and technology has been transferred to the industry. And we have conducted more than 10 field trials in case of stationary as well as mobility applications. And we have a very good strength of making core component for fuel cell, which is membrane electrode assembly, which will core component for fuel cell. And using the developed stack, we have tested extensively and delivered more than 200 kilowatts power. And we have tested our fuel cell stack because when you want to introduce a new technology, the ultimately the durability and the endurance test has to be carried out. So we have done a very extensive endurance test, more than 8,500 hours. And as I said, we also produce parallelly about 10 plus PhD in this area through our centers. And we have very good publications and handle more than 100 course worth of project throughout these 2 decades of experience. And these are our various development ranging from 1 kilowatt to 20 kilowatt fuel cell over a period of 2 decades, and which has been demonstrated for various applications. And especially we have done a demonstration with the Navy Lignite Corporation, where they have the hydrogen as a fuel, and Gas Authority of India Limited, where they are also having hydrogen source. Using that hydrogen source, they want to convert the hydrogen gas into power, so which is kind of green electricity. And we have also coupled with their own premises, and the entire premises was being powered through hydrogen fuel cell. And recently we also demonstrated with Baba Atomic Research Centers, so for green power generation. And recently we did a demonstration with the Tamil Nadu government as a kind of disaster management. Say, for example, so if you don't have a power supply in disaster conditions, so if we have a hydrogen truck actually where you can have a commercial hydrogen cylinders, using the hydrogen cylinders, we can deliver the power about 5 to 10 kilowatt depending on the need. So it's a kind of hydrogen truck. We have done a demonstration for the disaster management with the Tamil Nadu government. So these are the various field trial which we carried out using hydrogen powered hydro stationary application as a kind of backup power applications. And apart from the station application, we also carried out demonstration as a kind of transport application, because when you do like EV electric vehicles, so we can also use a hydrogen powered two-wheelers and three-wheelers. So we have done a demonstration with the battery actually, because it's a kind of range extender. So if you use pure battery in the vehicle, then it's basically it's electric vehicle. But when you couple with the couple with fuel cell, the fuel cell will charge the battery on board actually. So if you have a metal hydrate canister or hydrogen cylinder in the vehicle, so using that hydrogen, the fuel cell will deliver the DC power. and the DC power is being utilized for the charging the battery. So it's a kind of onboard charging of battery, so that it can be considered as a hybrid two-wheeler along with battery. And apart from the two-wheeler, we also did a three-wheeler and four-wheeler application. I mean, three-wheeler application using various capacity of the fuel cell, whether it's 3 kilowatt and 5 kilowatt, as a kind of hybrid fuel cell electric vehicles, actually, along with the battery. And as I said, you can directly use hydrogen as a fuel in the IC engine, but the challenges is that the kind of, because it's a lighter gas and air fuel ratio mixing is more actually. So it occupies more combustion chamber actually. So that occupied engine capacity is more. So, and second occupies, it occupies more volume in the combustion zone, and it also emit NOx, because you are allowing hydrogen directly in the IC engine, and oxygen is the oxidant. So normally it can end up with NOx emission actually. And it has a low efficiency, as I said earlier, low efficient. Because of these disadvantage, the hydrogen IC engine is not taking off. It's not taking off so far. And there are positive and negative when you use this hydrogen as a fuel in IC engine. As I said, the NOx emission and the efficiency is a major criteria, which is low. In the case of NOx, is high, and in case of emission, in the case of efficiency, it is low. And though it has this kind of disadvantage when you use hydrogen in the IC engine, but recently Ashok Leyland has done an extensive demonstration and the field trials using their own buses, long trucks, heavy trucks, where the hydrogen is being powered in IC engine, and they have demonstrated using the type 4 carbon fiber composite cylinders, because you need to carry more hydrogen for this kind of application. So if you want to carry more hydrogen, then you cannot use a steel based cylinder, because it occupies it carry less hydrogen. So if you want to carry more hydrogen, then you have to end up with carbon composite cylinders, so which can handle hydrogen in more volume and high pressure. And so that the vehicle can be demonstrated using hydrogen powered IC engine, IC engine, and apart from the fuel cell. And but when you want to use the hydrogen in a fuel cell kind of cars, actually, so there are two kind of mechanism. So as I said, you need to have a battery, even though it is in hydrogen fuel cell, because this BOP, balance of system, has to be initially powered. So because say for example, if you want to turn on the air blower, or if you want to turn on the control system, so you must have a power source. So in that category, the battery with the lower capacity is being integrated with the fuel cell. So this is a typical, typical components required for making hydrogen fuel cell works. There are two ways of fuel cell hybrid vehicle. One is series hybrid, another one is parallel hybrid. In the case of series hybrid vehicle, the fuel cell capacity will be small and battery bank will be large. Whereas in the case of parallel hybrid, the larger will be the fuel cell capacity and small will be the battery bank, so that you can meet the required power demand, create power demand for the motor, which is take care of the running activities of the vehicle actually. So the fuel cell vehicles, actually the requirement of fuel cell vehicle is, there are four important requirement. One is it should meet the peak power demand immediately. So that means the transient response time should be within 1 second, and it should also cover the range actually, because say for example, if you want to cover range more than 350 to 400 kilometers actually, so you need to carry 5 to 6 kg of hydrogen actually. So that means you need to have a very good storage mechanism in the vehicle, so that you can cover the entire range, and the response time has to be high, and it should be capable of say okay, if you want to turn on the fuel cell and if you want to power the motor, so it has to be turned on even at a low temperature. So low temperature to high temperature. So operational range, this window, the temperature window has to be from minus 20 to plus 50 or 60 degrees Celsius. So these are the major requirement for fuel cell electric vehicles. And this is a key component for fuel cell electric vehicle. You must have a fuel tank which is having carbon composite cylinder, and it carry more hydrogen, and you must have a fuel cell like IC engine. It will convert the hydrogen into power, and other DC converters and inverters are essential, and power electronic controller and auxiliary battery and fuel filler and battery bag and fuel tank. These are the major key components for any fuel cell electric vehicles. And apart from the transport applications, right now, this fuel cell is being widely used as a backup power application actually. Especially in the telecom sectors, they may require 3 to 5 kilowatt power when the grid is not grid power is during failure of the grid power. So it is mandatory. They must have most of the telephone tower operators. They are using diesel engine as a power backup. But there are government guidelines are insisting to come out from the fossil fuel based power backup application. So they need to go with the advanced hydrogen energy based power backup application. So where you have a hydrogen storage cylinders in the station, and through this the hydrogen through the fuel cell is deliver power 3 to 5 kilowatt, and it can meet the demand required for the telecom tower. So the telecom tower is one of the key application area for fuel cell. It's a kind of backup power application. Even in India, apart from the developed countries, even in India, there are Reliance and Aditya groups. They have operating many telephone tower, which is being powered by the fuel cell, not by the diesel. And apart in case of transport application and the global sector, there are all the leading automobile manufacturers like Hyundai, Toyota and Nissan, all the leading automobile manufacturers, they have experienced the fuel cell powered, completely fuel cell powered passenger vehicles. And I also experienced the same when I was in Vancouver. So because this is being powered only through fuel cell. So they have a 700 bar storage cylinders and on board, and it carry 4 to 5 kg of hydrogen on the vehicles, and using that hydrogen they have a very good control mechanism for controlling power. And the each vehicle capacity of the fuel cell is about 110 to 120 kilowatt fuel cell. You can find here the fuel cell which is very compact and which can serve the need of 110 to 120 kilowatt power while on board actually. And apart from the passenger applications, there are other demonstration program. Hydrogen fuel cell powered powered train is also being demonstrated in China and Germany. Even in India, it is soon we can also heard hydrogen fuel cell powered train very soon. So these are the initiative which shows the hydrogen can be an alternative fuel for any stationary as well as mobility application, which will help in reducing the carbon footprint, and which is need of the hour for any smart cities or smart energy generation. And as I said, when you compare with this fuel cell electric vehicle and battery electric vehicle, there are three important characteristics in terms of price, range, and time to refuel. So in these categories, if you see this hydrogen fuel cell electric vehicle, right now the cost is high because of the low volume of usage actually. So in over a period of time, this cost has also come down when the number of usage is going to be increased. So in that case, the price is not an issue for hydrogen fuel cell electric vehicles, and the range is also on par with the fossil fuel. You can cover 350 to 400 kilometers range. And unlike battery-based vehicles, we need to have 150 to 500, but you need to have a proper infrastructure for the charging, which is time to refuel or time to recharge is high because it may vary from 1 hour to 12 hours. Whereas in the case of hydrogen-powered fuel cell vehicles, the refueling time is on par with the currently existing petrol or diesel or CNG-based vehicles. So the refueling time is very less. It's 3 to 4 minutes. So in that category, over a period of time, this hydrogen fuel cell electric vehicle will take off the battery-based electric vehicles actually. And as I said, this kind of net energy analysis is one parameters which the people are considered, because when I say battery, when you have a battery-based electric vehicle, you do want to go with the fuel cell-based electric vehicles. So obviously there are two parameters. One is energy stored on investment, and second aspect is the efficiency. So the energy stored on invested is nothing but the ratio between how much amount of energy which you are spending to make 1 kilowatt battery or 1 kilowatt fuel cell. Using that 1 kilowatt battery or fuel cell, how much power you are generating over a period of time. So that defines the energy stored on investment. That is the term. So in that category, you take renewable energy and split the water molecule into hydrogen and oxygen, store it. Whenever you require, you use it in fuel cell, you can again get back into power and water. So it is similar to battery charging and discharging mechanism. That's why this RHFC is nothing but regenerative hydrogen fuel cell. These functions are similar to battery charge and discharging mechanism. But the amount of energy which you want to spend to make 1 kilowatt battery is more than the amount of energy which you want to make 1 kilowatt fuel cell and electrolyzer. So because of that, the energy stored on investment for the fuel cell based electric vehicle is close to 60, that is 59. Whereas in the case of lithium battery, it is only 35. But when you see the efficiency, because when you generate hydrogen from the water, you have to give minimum 2 volt as the input. Whereas in the case of fuel cell, when you pass hydrogen in the same system, you have to get 2 volt as output. But normally we will get 1 volt as the open circuit voltage. Because of that, the efficiency is close to 30%. But there is a lot of scope for the improvement. The efficiency is close to that 45 to 50%. So when you consider that, actually, this efficiency also will go up, and the conversion efficiency is also low. Whereas in the case of battery, right now it is high, because if you charge 1 kilowatt battery, you can get back 900 to 850 watts as a output actually. So in that sense, the battery-based electrical efficiency is slightly higher, but over a period of time, because of novel technology and novel material development, there is a lot of scope for the reduction in the gap of voltage, so that efficiency can be improved. So and second advantage is it's completely green, where you cannot find any carbon footprint. So in that aspect, the hydrogen-based fuel cell electric vehicle will be the feature when compared with battery-based electric vehicles. So there are some key challenges. One is the cost. Right now it is high because of the low volume of usage. And second aspect is the required balance of plant components actually. Because apart from the fuel cell, you need to have other balance of system, fuel supply system, air supply system, and power conditioning system, and thermal management system. So all are equally important. So we need to focus on developing our own balance of system for the fuel cell, so that entire system cost can be come down. And as I said, though you generate fuel in an effective manner, you need to have a proper fuel infrastructure. Now we can find a fuel cell electric vehicle on the road, but where will you charge the fuel cell actually? So you need to have a proper hydrogen gas dispensing system like our CNG or petrol pump. We need to have a proper gas, dispensing system, so that the fuel infrastructure is one of the key challenges when you want to adopt a fuel cell based vehicles. And ultimately, if you want to introduce new technology for the commercial market, there is a difference between the price and cost actually. So the margin has to be less, so that the price, the cost of the overall cost of the fuel cell based electric vehicle will come down. So once the technology penetrations it happens, then obviously this difference between the price cost and can be easily understood actually. So so these are the major challenges which we need to overcome when you want to realize hydrogen-based economy. And in that sense, this artificial intelligence of hydrogen-enabled integrated system is playing an important critical role, because this hydrogen-based integrated energy system, basically you are getting power from the renewable, which are highly variable actually. So you need to predict based on the geographical location, you need to predict the amount of energy which are coming from the renewable, and using that renewable energy, how much amount of hydrogen which you can produce, and using that hydrogen, how much amount of uh, application in terms of uh, uh, mobility or in terms of backup applications. So all those things can be predicted. So especially these advanced data analysis approaches can be used to enhance the operational efficiency of and sustainability that help improve the system performance and economical benefit of hydrogen integrated energy system actually. So this artificial and machine learning, especially particularly the machine learning is well suited for handling these non-deterministic and continuous challenges of hydrogen enabled integrated energy system. So AI and ML is also important to predict the various malfunctioning of this energy system in case of hydrogen, whether it is coming from fossil fuel or it's coming from the water. Irrespective of this feedstock, these predictions can be done using this ML, and which is also need of the hour because it's a new technology for the commercial market. So it definitely would help in predicting these aspects so that we can get a clear picture on what would be the need for the society. And apart from these are the theoretical background analysis, we also require some kind of startups. These are the very major area where startups can focus on development of not only the core component, other balance of system component, and especially the hydrogen generation method with the low cost method. So these are some thrust area where the startups can focus on hydrogen fuel cell based electric vehicles to realize the hydrogen will be the thing. So apart from all these technological challenges, the awareness among the people has to be created. So in that sense, because the atomic weight of hydrogen is 1.008, which represents 8th October. So every year 8th October is being celebrated Hydrogen Fuel Cell Day. So we also celebrating Hydrogen Fuel Cell Day for the past 7 years by way of conducting various workshops and conferences so that the knowledge of technology knowledge can be penetrated to among the society. So the hydrogen can be the alternative fuel, and it can be used for backup power or mobility application, especially for the kind of smart cities. But I would like to conclude that though the hydrogen is a green energy, so but there may be a possibility for the carbon. Actually, right now the emission of carbon is more, but in future the hydrogen will be dominant with less carbon footprint. So that's what I want to conclude. So with this, I conclude my talk, and I'm open for any kind of discussions. Thank you. Hello.
Thank you, sir. Thank you for your wonderful presentation and knowledge sharing to us with us, sir. Thank you so much, sir. Dear participants, do you have any queries?
Good evening, sir.
Yeah, good.
Sir,
Yeah, you are audible.
Ma'am, either you can text in your chat box also, ma'am, your queries. I think she is not getting the line clearly, sir. Yes, sir. Thank you very much for your knowledge sharing, sir. Thank you so much, sir.
Thank you, ma'am.
Thank you, sir. Dear participants, please stay in line. We can start our session 2 soon.
Sir, thank you for your session, sir.